Welcome to the final part of this series. Today, we'll set the PA bias, check the RF power output, and do the final calibration of the radio. The LARCSet is connected to the Texas port of the power meter. And the ANT port is connected to a dummy load. I've also connected a current measuring setup to monitor live current consumption. The radio is powered using a 12 volt, 2 amp power adapter. Before switching on the radio, rotate the PA-BIAS trim pot fully clockwise. Now connect the microphone to the middle audio jack. Tip is mic, ring is PTT, and sleeve is ground. Press the PTT switch without speaking. The current draw should be around 170 milliamps. Now slowly rotate the PA-BIAS trim pot anti-clockwise until the standing current reaches around 350 milliamps. Next, speak clearly into the microphone. The current should peak around 0.6 amps, and on the 5 watt range of the power meter, you should see approximately 3.5 watts output. Now release the PTT and disconnect the microphone. Next, connect a Morse key to the rightmost jack. On key down, the current draw should be between 0.8 and 1 amp. Switch the meter to the 20 watt range. You should now see around 5 watts of RF output. You can further fine-tune the output by adjusting the BPF coils. After successfully completing the power amplifier bias setting of the PA, it's now time for the next important step, calibrating the dial. Now, the LARCSet is a fully analog radio. That means there's no digital frequency display here. But honestly, that's part of its charm. And because it's analog, one of the simplest and most practical ways to calibrate it is by manually marking the frequencies on the dial using a simple Sharpie marker. This is our favorite method because it's quick, reliable, and requires very little equipment. For this process, you'll need access to another radio transceiver that can transmit CW signals on the 7 MHz band. In this setup, I'll be using a uSDX transceiver operating in CW mode. On the LARCSet, I've connected a small wire loop antenna assembled on a BNC male connector. This tiny loop is enough for receiving the nearby calibration signal. Meanwhile, on the uSDX transceiver, a dummy load is connected to the antenna port using a jumper cable. This prevents any unnecessary RF transmission while we calibrate. I'm also using an external speaker for easier audio monitoring. And one more important thing, the LARCSet is powered using a 12 volt lithium-ion battery instead of an SMPS power supply. This helps reduce switching noise and makes tuning much cleaner. Now let's begin the calibration. First, tune the transmitter radio, in this case the uSDX, exactly to 7.000 MHz. Set the mode to CW. Now press and hold the CW key or transmit key on the uSDX. On the LARCSet, slowly tune across the band until you hear the CW tone clearly. Once the signal is tuned in properly, mark the position of the tuning pointer on the front panel and label it as 0. I'll fix this in place so you can clearly see the marking process. I'm using this big measuring cup to keep the board upright, allowing the camera to capture all the steps. Now let's begin the calibration. First, tune the transmitter radio, in this case the uSDX, exactly to 7.000 MHz. Set the mode to CW. Now press and hold the CW key or transmit key on the uSDX. On the LARCSet, slowly tune across the band until you hear the CW tone clearly. Once the signal is tuned in properly, mark the position of the tuning pointer on the front panel and label it as 0. That mark now represents 7.000 MHz. Next, move the transmitter frequency up by 10 kHz to 7.010 MHz. Again, press the CW key on the uSDX and tune the signal on the LARCSet. When the signal peaks, make another mark on the dial and label it as 10. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Repeat this same process every 10 kHz across the band. Over time, you'll build a complete frequency scale on the LARCSet's front panel. Of course, there are many different ways to calibrate the LARCSet dial. But the most important thing is making sure your operating frequency always stays within the amateur radio bands. And with that, your analog dial is now ready for real on-air operation. And with that, the calibration is complete. Thanks for following this entire series.